Hey guys, this is Mr. Yo, and today what we're going to do is we're going to go over some of the previous lesson we talked about from last week. And going forth, we're going to learn about some new concepts that continues on with whatever we're learning today. So, what we're going to go over right now is we're going to talk about predicting the product of chemical reaction. Okay. So from that part, there are four parts that we're going to talk about. One is the diatomic molecule and charges, the polyatomic ions. There's a lot of memorization for this part, but I will try to help as much as possible. Then we have the type of reaction and predicting products. So here we go. So diatomic molecule and charges. These are stuff that we have been talking about ever since probably from our 2 units ago. We did a lot of practices, and also we made a flip book that has this information as well. So if you guys want to take a picture of it, keep it somewhere that you can use, please do so. Okay. You will eventually have to memorize this, but this is a pretty simple topic. So this part is something you guys have to remember. The first column, it starts out with a +1 charge. Next, we have a +2 charge. And then skipping all the way to group 13, we have +3. Next is plus and -4, -3, -2, -1, and 0. Just as a reference, the reason why we have a 0 charge right here is because there is a full 8 valence electrons. Okay. 8 valence electrons. We talked about this last time. If there's 8 valence electron, it's too full. It doesn't want more electrons. Therefore, we are not going to have any charges in the noble gas area. Okay? So always remember this, and we're going to have a lot of practice in relation to using this chart as well. Next, we're going to talk about diatomic molecule. Now, this is actually in your flip book as well. However, we only talked about this probably 2 units ago or a unit ago, but now we're going to actually use this concept on our predicting the product. So, whenever you see the following, we have Br, I, N, Cl, H, O, and F. Sometimes I call it as Brinkelhoff. It's a way to remember this diatomic molecule. And these 7 elements will contain a 2 as a subscript. If you guys don't know what a subscript is, here's an example. If I say Br, okay, we're going to put a 2 on the bottom right corner of the element. Okay, now this only happens when the element, okay, is by itself. If the element's by itself, make sure to put that 2 right next to those given elements. Okay, you can also remember this by not only Brinkelhoff, but also just like the image. It kind of looks like a number 7 with a hydrogen all the way at the top left corner. So either way is totally fine, but always remember that if the element is by itself, that's the key word, remember that, you should have a 2 at the end, just like our example on the top. Okay? And that's pretty much it for this part. Now, moving along, we have the polyatomic ions. This is the part that you're going to have a lot of memorization on, but some reviews as well. I call this as the old polyatomic ions because we talked about this during class, okay? So we have no, so, co, po, clo, no. That was one of the method we said to remember as a way to memorize things. Now, as you can see, these following parts contains an ATE ending. ATE ending. Okay? The reason why I'm focusing on this ATE ending is because if we go on to the next slide, we have the ITE ending. Now, the difference between these two are the following. Okay? The number of oxygen is one less than the ATE ending. Okay. Also make sure that the charges stays the same. Okay. Here's an example. We have nitrite. Okay. Remember that nitrate, on the other hand, is NO3 1 minus or -1 charge. But what's happening right now is that this oxygen right here, it's going down to an O2. The N still goes down and the charge stays the same. Okay? So this is the difference between the ITE and ATE ending. So always make sure to keep this in mind whenever you're dealing with this kind of problem. Okay? Don't get confused. Now, some of you guys had some problem with the homework assignment. When you have an IDE ending, this means that we're just talking about that specific element. Okay? Not polyatomic ion. So always make sure to keep that in mind. I'm talking about the element, not the polyatomic ion. For example, let's say that we have nitride. Okay, this one has an IDE ending. That means the answer is not NO2 or NO3. It's going to be letter N. Also, make sure to use the charge that we talked about previously, which is the -3 charge. Don't get confused with the charge of the polyatomic ion. That is very, very important. One mistake will cause you a lot of problem. Okay? So make sure to remember this. Feel free to pause in each individual slides so that you can get caught up with these notes. Okay? Now for all the honors kids, remember, there are more things that you need to remember. So try to remember all these informations as much as possible. If you have any questions, feel free to ask. Okay? Same goes with some more information. Okay? And that's it for polyatomic ions. It's more of a memorization, and we're going to use that to combine chemical formulas and also some naming as well. So make sure to remember the naming and the chemical formula. Now here's the easy part, which is the type of reaction. A lot of you guys remember this because I've been giving you some silly examples relating with these concepts. For example, synthesis. When we say synthesis, it means combining. Okay? I believe in the Google, if you type in synthesis, it actually has a synonym of combining or combine. So that is also a way to remember synthesis. So if you're combining something, we have letter A or an element, B or an element, creates AB or a compound. Okay? So always make sure to remember this when you're trying to determine what type of reaction the given chemical equation is. Next, we have decomposition. Decomposition means break or breaking down. Okay, either one's totally fine. They pretty much has a similarity between it. So decomposition or decompose would also be another one as well. So we're separating from A, B to A and B. So a compound change into an element and an element. Okay? And then these are supposed to be an arrow sign. Now, this is the part where I wanted to emphasize, same goes with the synthesis. Always make sure, don't forget about the diatomic molecule. Okay? In this case, the hydrogen and the oxygens are by themselves. So you must have a 2 as a subscript there. Okay? Next, we have single replacement. Single replacement, remember as drop and swap, or an example is like a couple and a single person. Okay, I gave you an example about this, how one person cheats on the other and decided to partner up just like that. So we have, in this case right now, we have letter C cheating on to letter A. And that's why A partners up with C, but B is by itself. Okay. Now in this case, always remember that the metal goes in front of the non-metal. Don't write it as non-metal and metal. I'll give you more example about this at the end, but make sure to remember that. Metal goes after the non-metal. Positive charge goes after, or goes before the negative charge. Okay? So that's how it is. So if you have any other questions, feel free to ask during class, line time, or through email. Okay? Double replacement. Now this time it is dropping and swapping, but also at the same time we have two couples. Two couples want to cheat on with one another. So A goes with D and C goes with B. And that's how we got that product. So always remember those concepts when you guys are solving the question. So it says, make sure to check the charges when swapping. Okay, I'll give you more example about this, but what I'm trying to say here is do not look at the given numbers like these. Okay, those represents the charge of the element. So if you were to predict or figure out what comes next, don't put that 2 right away here, and don't put that 2 right away for Na as well. Okay? Always check the charges. That is the main point. The charges. Charges are your friends. Next, we have combustion. Now, the reason why combustions are usually easier to remember is because it's only one type of equation. Okay, there's nothing changed with it. There's an organic element, an oxygen, carbon dioxide, and water. Okay. Nothing else happens. There's no other different products being made in combustion. So another way to remember combustion is kaboom. If an explosion comes out, okay, there's carbon dioxide and water in the environment. So that's an easier way to remember this. So make sure to remember combustion. And I believe that is all for all the 5 different types of reactions, chemical reactions. Okay. So now it's your turn to predict the product. Okay. There are a couple informations or steps that you need to remember. It's not too challenging, but make sure to follow these steps when you guys are predicting the product. It's very important. First is examine the reactant. Okay. Always make sure, does it have a cation? Remember, cation is a plus charge. Does it have an anion? Is it a polyatomic ion or oxygen gas, organic compound? That is important. Next, determine the type of reaction. The reason why we're determining the type of reaction is because it will help us figure out what our product is. Number 3, when you're combining different elements together, make sure to know their charges so you can write out the correct compound at the end. And last but not least, number 4, some of you guys might hate it, some of you guys might like it, is balancing equations. And we will go all 4 of those steps for this process. So here's an example. We have calcium plus chloride. So right now, what do we have here? We have what? So feel free to pause the video before moving on to the questions and looking at the answers. All right. So as you guys can see, we have calcium and chlorine. It both has a cation and an anion. So for example, calcium has a Ca2+, while chlorine has a -1 or 1-. That is another way to remember or keep on track of what kind of charge each element has. Now, what type of reaction will this be? If you guys remember from last time, we had an element plus an element. Might give you guys some hints about it. So pause the video and here we go. It's a synthesis reaction. An element, okay, plus an element. And obviously that means you will get a compound. Now this way we will be able to figure out what our answer is. So now we're going to figure out the charges, +2 charge, -1 charge, and a chemical formula if you crisscross applesauce. Now, I don't know why this happens a lot, but a lot of you guys are a bit confused of how to do crisscross applesauce. Number 1, forget about the charges. Okay, forget about the charges. Number 2, crisscross the numbers. Okay, crisscross the numbers and place them on the bottom right corner. Okay, not on the top, the bottom right corner. So in this case, we have 1 going over here and 2 going over to Cl. So if we combine them together, we will end up getting CaCl2. You could potentially put a 1 here if you want to, but it really doesn't matter. Usually we don't put anything down because 1 basically means there is a calcium. Okay, without it, with the 1 or without the 1, it's still calcium. And last but not least, we have to balance. Okay, now how do we balance this? What I usually do is, after we write down our product, I make sure that I write down all the elements that are given to you on the left and on the right, but pretty much it's the same. Then we're going to write down how many there are on left and on the right. In this case, we have 1 and 1. They're both the same. And 2 and 2, which basically means this is balanced out. And that's how we do it. Okay? So if you guys have any questions, feel free to ask questions. And what I like you guys to do is, if you guys can ask your colleagues or if your classmates of how to solve these questions, I mean, that's a good practice for you guys too, to remember. So make sure to follow these steps. I know there are other questions like this, but I'm going to quickly go over this so I can give you guys some more example problems. Right now we have, let's see, what do we have? We have a cation, and an anion. Okay, so just like what we have here. Now, what type of reaction is this? If you guys can see it, we have, sometimes I plug in the charges just to show you guys the difference. Okay, if you guys are confused where I got the 3+, is because of the 3 in front of the F. Remember to uncrisscross this time if you want to figure out the charge of your transition metal. So now this type of reaction, we have a couple and we have a single person. So obviously the next step would be single replacement. Now finding out the charges, I already showed you the charges. And if you combine the pairs, so this time remember, positive charge goes with negative charge, okay? And this positive, the iron, is probably going to be by itself. So the answer in this case is AlFeF3 and Fe plus AlF3. This is all balanced out, so I wouldn't have to put anything down. All right. Moving on to the next one, we have the organic compound and we have the oxygen. So obviously right now we have the organic compound, oxygen, and we know it's combustion because the combustion equations are always the same. Now the product would be obviously CO2 plus H2O. And we got to balance it. Now the balancing part of this part is slightly tricky because combustions usually have like a back and forth feeling of balancing. So let's balance it out just as a practice. Carbon, hydrogen, and oxygen. Right now we have one carbon on left, 4 hydrogen left, and 2 oxygen. We have 1 carbon, 2 oxygen, and when we have 2 oxygens or 2 types of oxygens separated with a plus sign, I usually put a 2 plus 1. There's a reason why I did that. Next, I'm just going to check out what I can do. So I'm going to put a times 2 here to make it 4 by 4, which means I'll plug in a 2 here, and that will distribute, which means the oxygen on the right side that has 1 will be multiplied by 2. So this is the reason why I did this. Remember PEMDAS, 2 times 1 is 2, 2 plus 2 is 4. Now, in order to make the oxygen on the left side the same, I have to multiply by 2 to get 4. So I put a 2 there. And there you have it. That's all balanced out. So make sure to practice more. Make sure to finish all your homework assignments. And make sure to ask questions if you guys have any questions. So let's solve some problem as we go along because practice makes make everything perfect. All right. So, for example, let's do this one. Let's say that we have H2SO4 plus NaOH. Well, first of all, what type of reaction will this be? To figure that out, we got to make sure that we plug in the charges. So hydrogen, we know it's a +1 charge. SO4, that's the polyatomic ion. So that's sulfate with a -2 charge. Sodium has a +1 and hydroxide has a -1. If that's the case, we have a couple and a couple. So that would be a double replacement. Okay. Now that we know that that's happened, what we're going to do is we're going to partner it up. So positive goes with a negative. Positive goes with a negative. So in this case, if we have H plus and OH minus, now this will obviously give you water, H2O. You can either write down H2O, so I'm going to put a parentheses over here, H2O, or you can write down HOH. I personally ask you guys to write down OH here is because it will make it easier for you guys to balance it out. And I'll show you why. Plus, we have Na plus and SO4 with a -2. Crisscross applesauce, that'll give you Na2SO4. Okay, so now that we have the product, we have to balance this out. That's the last step. So what I'm going to do is I'm going to make sure that I write down the chemical formula or have a clean sheet. okay? Just to avoid any confusions and wordiness, whatever you guys want. So what I'm going to do is I'm going to write down each of the elements here. H, okay, Na. Now, when you have a polyatomic ion that is written the same way as it is on the left and on the right, you can just write it as it is, okay? Same goes with the OHs as well, hydroxide. Now I'm just going to make sure that I write down the amount. We have 2 hydrogens on the left, 1 Na on the left, 1 SO4, and 1 OH. For hydrogen on the right, we have 1 hydrogen, 2 sodium, 1 SO4, and 1 OH. Now I'm just going to simply just multiply it out. So that will give you a 2 here. Always make sure to distribute. So the OH times 2. So I'll multiply 2 here as well. Put a 2 here. Hydrogen gets multiplied by 2 as well. And last but not least, well, let's check if it's balanced. So we have 2 by 2. Check. We have 2 by 2. Check. 1 by 1. Check. And last but not least, 2 by 2, check. So there is your answer. If you're still confused, make sure to come after school or come talk to me so I can help you out understand this. But this is how you predict the product. Okay? So now what I'm going to do is I'm going to give you another example, but this example this time includes diatomic molecule. So let's see. I'm going to put probably BaO plus, let's say H. Okay. So what am I going to do? What type of reaction is this? If we have, well, we need to find the charges. So actually, before I move on, make sure to pause the video and answer the question, then check your answer. Okay. All right, so Ba is a +2 charge. Oxygen is a -2 charge. Hydrogen is a +1 charge. So we have a couple, we have a single. So that is a single replacement. Now, what I'm going to do is I'm going to make sure that the positive charge goes with the negative charge. Now, Ba this time will be by itself. Now, if it's not a diatomic molecule, just make sure not to put any 2's or any numbers on it. Just Ba would be fine. Plus H2O, so always forget about the 2 because whenever we're balancing it, it's all depending on the charges. Okay, so that means this will become H2O. Now, if we were to try to make sure that it balances out, Ba, O, and H, we know there's 1 Ba, 1 oxygen, 2 hydrogen on the left, 1 Ba, 2 hydrogen, and 1 oxygen. Check, check, check. And this is how we solve these kind of problems. Okay, so make sure to complete the worksheets that I provided for you guys, and make sure to remember your charges and polyatomic ions. If you have any other questions, make sure to ask questions because I love questions. Anyways, that is all for today. And the last message I will show you is you did it. So send me an email, ask me questions after class or after school, and I will see you guys next time. Good luck.